Hello students, welcome to Memonit. I am Shubham. I am a physics SME in Memonit. So today the thing we are going to discuss is the BPT3, the Brahmastra part test 3. So it is comprises of three chapters. Like the two chapters are in BPT2, BPT1, and the one chapter in the BPT2. BPT1 there is one chapter, that is the basic mathematics. Like it should the basic mathematics problems that gonna help you guys, and like doing this, like that differentiation, the integration, or the coordinate geometry. And the next one is our this units and dimension chapter. That is the fundamental of this physics. If you understand the units and dimension properly, so that you can the complex problems gonna be in the complex problems, you're gonna it's gonna be good. Okay. And in the BPT2 there was the electrostatics chapter. Okay, that one is the that is from the plus 2 class 12th, the first chapter of the plus 12th. So you guys, I think you guys have the planner, BPT planner with you. So it is designed in that way so that it can cover the class 11th and class 12th chapter like simultaneously. Okay, so in the BPT3, so there are three chapters. Like these three chapters are there. Those chapters were in the BPT1 and BPT2, and this BPT3 is the accumulation of these two chapters. Okay, so now so without wasting any time, right? So without wasting any time, let's get into the solving of these questions. So the first question is from the differentiation of the basic mathematics. Differentiate y equals to sin x by cos x. So what do you know? Sin x by cos x means tan x. It is tan x. Okay, and the tan x and the if you differentiate tan x, if you remember the formula, so if you can do the differentiation of tan x, it will directly give you sec square x. Okay, it will be sec square x. And there are another method, that is the more lengthier method, that is the dividation formula. What is the dividation formula? Tells us, like if you do the denominator square, it should be cos square x. In the numerator it should be sin x, sorry, cos x, ddx of sin x, it should be cos x. Okay, minus sin x into ddx of cos x, that is equals to our this. So in the numerator it will become 1. So cos sin square x plus cos square x, it will become 1. So this will become sin x. Okay, cos x equals to cos x, the differentiation of cos x equals to minus sin x, so it will become sin square x. So this is cos square x and this is sin square x. So sin square x plus cos square x means 1. So 1 by cos square x, it will become sec square x. So these are the two methods by which you can solve this. Okay, sin square by the direct formula of tan x, and from this sin x by cos x, you can apply the dividation rule of this differentiation. Then and then you can achieve the desired result, that is the sec square x. Okay, now moving on to the question number 2. If force F, area A, and density D, okay, are taken as the fundamental quantities, then mass can be represented. Okay, so you know what is mass? Mass is nothing but volume into density. Okay, so here, and volume, what is volume? Volume is nothing but area. Okay, so volume is nothing but area. But if you do this approach right, what will happen? So here it has been taken that force is a fundamental quantity. So we have to approach this one. F is equals to ma from the Newton's second law, right? So here F will become equals to mass into acceleration. Now here all the things, this F is given as a fundamental quantity. Aim is you have to you have to calculate the dimension of aim you have to calculate. And now what it is unknown, the dimension of this A, the acceleration dimension, that is the unknown here. So how to calculate the dimension of A or any acceleration? So there is a formula, right? You guys know, I think from the liquid chapter. So it is that the force by area, that is the pressure, that is given by rho gh, where rho is the density, g is the acceleration, and h is the height of the object or the depth of the object from the water surface or the liquid surface, right? So in this formula you will get the dimension of this g, that is the dimension of acceleration only. Okay, so g or a, whatever you say, it will become f by a rho h. What is h? F is a fundamental quantity here, a is the fundamental quantity, and rho or d, density d, dimension of rho is here d, and h, what is h? H is nothing but the dimension of h will be the L, okay, the length. And if you just do one thing, if you square root the dimension of a, area, that is equals to L square. Okay, if you square root the dimension of a, right, root a, it will become what? It will become L only. So in place of h we can write root over a. Okay, so here it will become f d minus 1 a to the power minus 3 by 2. Okay, minus 3 by 2, right? So if you put this like this one, a, in place of a, if you put this dimension of g, you will get the dimension of m. M, what will it become? M is equals to f by a, right? And f is there, dimension of a we got f d minus 1 a to the power minus 3 by 2. Okay, so f cancel out, it will become d a to the power 3 by 2, d to the power 1 a to the power 3 by 2. The dimension of this will become f naught is equals to our d into a to the power 3 by 2, that is the dimension of mass. So we got the approach, right? We have to have the knowledge of this one. The pressure is equals to rho gh. Okay, that is the main here, that is the main formula you have to remember. Okay, now moving on to the question number 3, that is the first one from the class 12th, that is our combination of this capacitor. Capacitive network of complex combinations shown in the figure. The energy stored in the capacitor. So energy of capacitor is given by the formula U equals to half CV square, where C is the capacitance and V is our this, what to say, V is our potential, like the terminal potential. Okay, so in the given figure, so there are, you can say 1 2 3 resistance, 3 capacitors are there. Okay, 3 capacitors are there. So yeah, so these 2 capacitors, 4 and 2, right, these 2 are in the series connection with each other. So therefore, sorry, not series, they are in parallel with each other. Okay, so therefore from the parallel formula CP is given by the formula C1 plus C2. So here C1 is 4 and C2 is 2, it will become 6. Now this total circuit are in the parallel connection with this 6. So therefore not parallel, it is in series. Okay, so therefore the CS, the formula of CS, direct formula is there, that is, what is that? C1 C2 divided by C1 plus C2. Or you can do this by this approach also, 1 by C is equals to 1 by C1 plus 1 by C2. That is also, that the general form of this is this one. Okay, so from this one we can say, if you put the value of C1 as 6, this is a 6, this 6 and divided by 6 plus 6, you will get 3. Okay, so 3 microfarad. 3 microfarad means 10 to the power minus 3 into 10 to the power minus 6 microfarad is there. Okay, understood, right? So this is the C, and we have to calculate the common voltage, like the common potential. How to calculate common potential? First of all, you have to calculate the total charge in the circuit. What is the formula to calculate total charge? Q equals to C into V. C is, we already got 3, and this potential is given as 20, this potential 20, so it will become 60. Now what we have to calculate, like in the 4 microfarad capacitor, like the potential at 4 microfarad capacitor, here you have to calculate the energy stored in the 4 microfarad capacitor, right, 4 microfarad capacitor. Okay, so it is like, it is not mentioned, I think it should be like it should be calculated in the 4 microfarad capacitor, right? So in this, what you have to do, potential difference across 4 microfarad you have to do. Okay, so this is the thing we have to do. So how to calculate? So here we got the C is equals to 4. Okay, now you have to calculate the potential at this 4 microfarad. Potential difference across the 6 microfarad, this microfarad is this 6 total, this one is what I have to calculate is the total. You have to calculate this, you have to take into account the Q, the charge, as this 6, this one and this one, these two are in series, therefore their current or the charge flowing through it is equal. Okay, so therefore here the charge is Q, here also the charge is Q, right? So the total charge, the potential, so to calculate the potential at this 2 and 4, how to calculate it? So if you divide the total charge by this the capacitor, you will get the potential of this one. So it will become 10 volt. Okay, now in the, if these 4 ohm, the 4 microfarad and the 2 microfarad, they are in parallel, so therefore their potential will be equal. So the potential across this 4 microfarad will be 20 minus 10, it will become 10 volt. Okay, so now to calculate this energy, the formula I already told you, this half CV square. So half C, the value of C is already given, this we have to calculate for 4 microfarad, it is, in place of C put 4 and in place of V put 10 square, so it will become 20 microjoule. Okay, all things are in micro unit, 10 to the power minus 6 unit. Okay, understand this. Okay, so I think you understood, right, what you have to do. First of all, first of all understand which two are in series, which two are in parallel, which are in parallel. Okay, according to that you put this in the formula, and the last one, what you have to do, for the last one you have to calculate the energy by half CV square. Energy is equals to half CV square. From that formula you can calculate it. Okay, the next one is for the system shown in the, if the resultant force on Q is 0, calculate Q. So this is a stable figure. Okay, so you have to calculate the value of this Q, capital Q, this 2 are, you have to calculate the value of capital Q. Okay, so what to do? Okay, so now if we calculate the distance, first of all you have to calculate the distance between this charge and this charge. Okay, so for calculating this charge and this charge, what you have to do, you have to this should be not capital Q, this should be small q. Okay, you have to calculate the value of small q, this q and this q, right? So what you have to do, first of all you have to calculate the distance between these two. What is the distance between these two? This is the this is our diagonal. So what is the so calculate the value of diagonal is given by a root 2. It is given by a root 2, where a is the side of the, this is, if this is a square, the side of the square is given by a. Okay, now from the Coulomb's law, this is Coulomb's law. What is Coulomb's law? Says F is equals to k q dot q1 dot q2 divided by distance, the square of the distance between them. Okay, so if we calculate it, it will become it will become kq square by, it will become kq square by 2a square. If we root this, if we just apply this square, so it will become 2a square. Okay, now if you see in the figure, the resultant figure, okay, so here there is a force acting in this direction and the force acting in this direction. So the resultant will be acting in this direction only according to the vector law. Okay, so from this we can say this this kq square by 2a square, it will be equal to root 2 kq square by a square. Okay, so if we just equate it, what we will get? Q is equals to 2 root 2 q, right? So this is the this is a very simple, and also the common numerical that is coming in the recent NEET papers. Okay, so you guys should understand this. So this should be done by the Coulomb's law, and you have to have the idea of the resultant force from the vector, this one, the triangle law, this one, this should be in this direction, this should be in this direction, so their resultant will be in this direction. Okay, right? And I think you understood, right? Okay, question number 5. If the radius of earth were to shrink by 1% and its mass remaining the same, then acceleration due to gravity on Earth's surface would be, they would decrease by. Okay, so what you have to calculate? So first of all, for calculating this, we have to take the into account this formula. This formula is given from the from where it is, like we got this formula from the Newton's laws of gravitation. That law gives us this: F is equals to G mm by r square, where capital M is the mass of this mass of Earth, and r is the radius of Earth, g is the universal gravitational constant, and we know F is equals to weight of the object is equals to mg. So this m cancel out, so g will become this. Okay, right? So now in the question it has been asked that what to the so if we can say that g is proportional to 1 by r square. So we have to calculate the error in g, and the error in r is given is 1%. So in case of, if you guys know this, the like in case of calculating the error, if that error is like if the relation between two things, these are directly proportional or inversely proportional, that doesn't make that doesn't like affect the calculation. So what affects the calculation? It is the exponents, whether it is cube or it's squared, or it is like fourth power. So this affects. So here the power of r is 2. So therefore the total the error of r should be multiplied with 2 only. So the total error in g will be equals to 22%, as g is inversely proportional to this r. So if g increases, r will decrease. If g decreases, r will increase. In the question it has been given that the if r is decreased, so therefore g will increase only. Okay, r is decreased, so therefore r is decreased, so therefore g will be increased, right, as there in inversely proportional relation. Next question, given, it is from basic mathematics. This can be taken as also speed, velocity also. S is equals to the distance covered. If you take this into account, this formula. So S is given t square plus 5t3. So you have to differentiate it. So differentiate for exponents differentiation. There is simple formula is there. D by dt, d given by x to the power n minus 1, n x to the minus 1 is the formula. So in this case, it will become 2t 2 minus 1 it will become. So it will become 2t, and here it is become it will become 1. Here the power of t is 1, so therefore it will become 1t 1 minus 1, it will become 0. So t to the power something to the power 0 is 1, so 1 into 5 means 5, so it will become 2t plus 5. Here 3 is a constant, and the derivative of constant is 0, so therefore this has no effect on derivation. If you derive it, so there is no effect of 3 in the derivation answer. Okay, now this is the maths type question. These kind of questions are asked like tremendously in the last few years in the NEET. Okay, list 1 is given as gravitational constant, gravitational potential energy, gravitational potential, and gravitational intensity. So gravitational constant can be taken from the formula this F is equals to gmm by r square. Okay, F is equals to gmm by r square. Yeah, this one. So yeah, this one. So to calculate the dimensional formula of G. So what it should be, G is equals to f r square like divided by m and m. So it will become m square. So if you calculate, this will become m square. This will become for the dimension of force is equals to ml t minus 2, and it will become L square. So if you calculate it, what will become ml2, ml1 and 2, it will become ml3 minus t minus 2, and divided by m square. So it will become 1 minus 2, it will become m minus 1 L L3 t minus 2. So this is the dimensional formula. Okay, just remember one thing: for the force, the dimensional formula force is ml t minus 2. Okay, this is from the F is equals to ma equation. Now gravitational potential energy has always the same thing. Energy is, for if we just remember the simple formula of energy, that is force into displacement. So force is ml t minus 2, and this will it is multiplied by the displacement, so it will become ml2 t minus 2. So it will become ml2 t minus 2. Okay, so this is the thing. This is the thing. You can calculate it from this, or you can calculate it from the simple formula of work and energy. From that you can calculate the energy. In any case, the energy looks like this only, ml2 t minus 2, force into displacement. Okay, and the next one, this gravitational potential. Potential is nothing but, if you guys remember, V is equals to W by Q. Gravitational potential is given by the work by mass. Okay, W by M. Okay, so work done, we already discussed the work done as the dimensional formula of ml t minus 2 as the energy, and mass is m minus 1, so therefore it will become m2 l minus 2 t minus 2. So it will become work done into mass inverse or mass. So mass cancel out, so what will remain? L2 t minus 2. That is the thing that is going to remain in the gravitational potential formula. Okay, now in the case of gravitational field intensity, it is given, it is the unit of this is Newton per kg. That means this is the unit of force. That means the dimensional formula will be ml t minus 2, and kg means m, so it will become mm cancel out, it will become L1 t minus 2. So if you check the options, so gravitational potential is given this option 2. Okay, and the gravitational potential energy is, so A2 B4, A2, just search for it, A2 B4 or A2 B4, and this one out of this. Okay, gravitational potential is given by the formula, this one, gravitational potential given by the formula L2 t minus 2, so it will become the first one. So A4, sorry, A2 B4 D, sorry, this will be C1 and D will be equals to 3 only. So if you take this, what will be the right answer? Our right answer will be the option number 2. Okay, now move on to the next one, question number 8. Question number 8 is like a tricky one. This is a tricky one. This question is a tricky question. A time varying magnetic field perpendicular to the time present plane is present in a cylindrical region of radius r. Choose the correct option. So this is related to electric field only. I think you guys will confused, but this is related to electric field only. So okay, so what do you have to do? So first of all, understand this: the charge is present at the surface of any sphere or something is there. Okay, so it is written that in the magnetic field perpendicular to the plane of the present of the cylindrical region as radius r. Okay, and we know where there is a magnetic field, there is also electric field present, right? So electric field is given by the formula E equals to minus dV by dr. That is the slope of potential. Okay, so we know that the EMF or E, whatever you say, it is given by d phi by dt. So if we just equate these two equations, this one and this one, so you will get minus dV by dr equals to d phi by dt. So from that equation we can say E equals to B by B is the magnetic field. Okay, so from that, in this equation you can say one thing, the value of this E comes as positive, so that we can say that the electric field is positive here. So hence you can say the electric field is only present outside the sphere only, not inside the sphere. As I already told you, as the Q charge is present at the surface, so therefore the electric field will also be present at the outer surface. Okay, there is no electric field present in the inside surface. Because of this, from this you can calculate, or from the basic knowledge of this electric field, that is of the charge that is on the surface, from that you can also calculate. Question number 9. 2 point charges are 3 meters apart and their combined charges are 8 microcoulomb. The force of repulsion between them is this. Okay, so 2 point charges, this is R, this is and their combined charge. Okay, so one charge is Q1, another charge is Q, another one is 8 minus Q. If you can write this way, force is given. So from this formula of like Coulomb's formula, there you will find a quadratic equation. Solve that equation, you will get the answer. Very simple question. Okay, so yeah, my screen is bloody. I don't know why. So from the simple thing, like it will become, it will become q 8 minus q into force. Force is here 0.012 into 3 square. Okay, it will become 3 square. So it will become 108. Okay, so their charge is microcoulomb 8. One is q and another is micro. So it will be multiplied with 10 to the power minus. If you take this into account, it will be 108,000. So yeah. This is the calculation. What did I told you? Okay, this you will find the quadratic equation. Solve that from q equals to q2. Put the value of q minus 8 in the q. Find the answer. So q1 minus q. So from solving this, q1 equals q1 plus q2 equals 8, q1 minus 2 equals to 4. So if we add this equation, q2 will be out. So q1 will become 2, will become like what will become 4. So q1 will become 2. So if one is 2, another one will be equals to 6. Right? That is the answer. If one becomes 2, another will become 6. Okay, in the next equation, power is given, distance is there, time is there. So P is equals to B plus x square by 80. The dimension of B by A. Okay, first of all, dimensional homogeneity formula. The relation, the dimension of right hand side should be equal to the dimension of the left hand side. And one thing, if two units, if two quantities are like added or subtracted from each other, the dimension is also equal. So therefore you can say dimension of B and dimension of x square by 80, they are also equal. Okay, so dimension of B is equals to dimension of P. B is equals to P. Okay, and dimension of power is equals to m L 2 t minus 2 divided by 2. That means it will become, sorry, divided by t, it will become ml2 t minus 3. Okay, so it will become ml2 t minus 3. Right now, 80, as I told you, x square by 80 has the dimension of P also same, or B, what you can, anything you can say. Okay, so from this you will get the dimension of A is equals to the dimension of P, that means P t square by x square. Okay, the dimension of P was ml2 t minus 3. So L, there it will become L square the denominator, so L square will cancel out. So it will become m t minus 3, and there is a dimension of this t, so it will become mt minus 4. So after calculating all of this, what we will get? We will get this b by a, sorry, the dimension of v. B by a will become ml2 t minus 2. Dimension of b is there. Okay, so dimension of B is there. So what you have to calculate the dimension of this B by A. So B by A dimension is ml2 t minus 2. So here the equation will be equals to B plus x square by 80. This is the equation. So it will become B by 80 plus x square by 80. So dimension of P is not equals to dimension of B. Dimension of P will be equals to dimension of B by 80. Okay, so yeah, it is like it is wrongly written here. Okay, so dimension of B by A will become the dimension of P into T from the dimensional homogeneity formula. P is there, ml2 t minus 2, t minus 3. So it will become into T means it will become ml2 t minus 2. So option number 1 is correct, ml2 t minus 2. Simple. Here it is like written in a very long way. I told you the short one, like B by A, from this B by AT will have the same dimension of P. So therefore B by A will be have the dimension of P into T. So P is ml2 t minus 3 and T is equals to capital T. So it will become ml2 t minus 2, because minus 3 plus 1 becomes minus 2. Okay. Now question number 11. Metal wire of radius this and this, the maximum percentage error in the measurement of the volume. Okay, so here it is a very simple one. Volume pi r square L. Okay, so I will calculate. We like consider the experiment. variables. So here the variables are r and l. So here the exponent is 1. It will lead to the error, that is the 0.0. Here it will be with the okay. Here the value is given as 0.1. So it will become, in place of r, it will become 0.002 divided by 0.1 into 2, because the exponent is 2 there, plus L by L. So here the L is given as 1, so we can calculate the error of L is equals to 0.1. We can take that. So if we calculate all of this, you will get 0.05. So multiply it with 100, it will become 5%. Sorry for that. So it will become what? It will become 5%. Okay. Now the next one, question number 12, that is a dipole problem. A dipole is initially aligned with the parallel to a uniform electric field. Okay, dipole, you get the idea. Dipole equals to P equals to 2QL. This is the formula. If the dipole is slowly rotated externally agent and at an angle of 30 degree with the electric field, calculate the work done by the external agent. Question number 12. Okay, so in the question number 12, what is being now? Calculate the work done. Work done is given by if you calculate the work done from this dipole formula, what you will get? It will get W is equals to P cos theta 1 minus cos theta 2. Okay, theta 1 and theta 2 are the nothing but the angle made by the dipole with the electric field. Okay, so here in the first position, the angle was, the object was at rest, so the angle is at 0 degree. After the theta 2 is given in the question is 30 degree, this one 30 degree. So if you put the value here, you will get PE cos 0 degree minus cos 30 degree. Cos 0 means 1, cos 30 means root over 3 by 2. So the answer will become P 1 minus root over 3 by 2. Option number 1 is the correct one. Very simple thing, just you have to know the formula. P equals to cos theta 1 minus cos theta 2. Okay, question number 3. A dipole is placed in an electric field as shown. In which direction it will move? Sorry for that. Okay, so here in the given figure, it is there are two charges, plus Q charges, minus Q charge, and the electric field is working in the outward direction. So to calculate this, how to calculate? So first of all, you have to the charge. Yeah. So as in the case of plus Q, the charge at plus Q, the electric lines due to which the electric field generates, the charge at plus Q is very less. Okay, charge is it is, the field lines are close together. So net force on the dipole acts on the right side only, this side. Okay, as the key is acting in this direction, so therefore the net force will be acting on this direction only. So therefore, as we know, as the electric field is given by the formula minus dV by dr. So electric field increases, this decreases. So therefore, as the system always moves to the from this to this, so that it will move towards the decrease zone, not in the increase zone. It will move towards the decrease zone. So therefore, option number 3 is the correct one. Okay, question number 1. Question number 14 looks very simple. Question number 14. So there are two quantities A and B. Their errors are delta and delta. So maximum possible error in A minus B. So I already told you there is no of this. So that the total, this will become error is given by the error divided by the actual value. So it will become del A plus del A. Okay. If you have to calculate this, what to say, the maximum possible calculation A minus B. If we take that Z is equals to A minus B, na, So what is the error? That is the del z. You have to calculate the value of del z. Del z is given by the formula z. If you calculate all of this, z is equals to z plus del z will become a plus minus del a minus b plus minus del b. So if we calculate all of this, you will get a minus b plus minus del a plus minus del b. Okay, so a minus b is already taken as z, a minus b already taken as z, so that means it will become z plus del z will become z plus minus a plus minus b. So z cancel out from each side, so del z will become del a plus del b. Okay, so that means option number 4, not option number 3. Option number 4 is the correct one. This is the correct option. So I was talking about this relative error, but here it is the error is like asked in the a minus b. So therefore option number 4 is the correct one. Okay, question number 15. Sin x dot cos x. You have to differentiate sin x cos x. The simple formula of multiplication you have to apply, that is a d dx of v plus b the differentiation of a. Okay, so here a is sine, so sine derivative of cos x, that will become minus sine, so that it will become minus sine square x, and this here in this and the plus cos x and the differentiation of sine x, so it will become cos x into cos x, so it will become cos square x. So cos square x minus sine square x plus cos square x, it can be rewritten as cos square x minus sine square x, which is the formula of cos 2x. So therefore option number 2 is the correct one. Right, very simple, just have to remember the formula. Okay, the surface densities on the surface of two charged spherical conductors radii 1 and radii 2 are equal. The ratio of the electric field intensities on their surface is so. Okay, so these two are connected. This in this question it is given that these two are connected. Okay, so here the field densities are sigma 1 and sigma 2, these are equal. So if you know this from the electric field formula, E is equals to Q by 4 pi epsilon naught R square. Okay, and this what to say, Q by 4 pi R square, Q by sigma is given by the formula Q by 4 pi R square. So if you put this, you will get sigma this E1 equals to sigma by E naught. You will get here sigma 2 by E naught. So if you take the ratio, it will become 1:1 only. So therefore option number 4 is the correct one. Always, this is always the factor. This will always be 1:1. Okay, three quantities are there: x, y, z. X is given by this, and z is this. So what you have to do for this case is just replace this units with the dimension. M is the dimension of mass, so unit of mass, so therefore the dimension would be capital M. Capital means L, so it will become square. Second is S to the power, T to the power. So if you take all of this into account, like after that, what if you solve this, like the dimensional homogeneity theorem, like this, take the relation between them is x to the power a equals to y to the power b, z to the power c, or you can take the proportionality symbol also. Just introduced one constant, that is equals to k, y to the power b, z to the power c. So I put the value of dimension of this. So you'll get there is a relation between a and the b. A is equals to b, 2a equals to c, and minus 5a equals to minus 2c. So solving all this equation, what you will get, that the relation between these two is the value of c is 2. So therefore the relation becomes x equals to y to the power z, x is proportional to y to the power z square. Okay, just solve this and you will get the answer. The way I told you, just x, y, z units and dimensions are there. The display. Okay, in moving on to the next question, question number 18. The displacement of the particle is given by x equals to this unit of k. Okay, the unit of k, you have to calculate the unit of k. So here the kt, in the kt, this kt part, this is nothing but the angle, and angle has no dimension, so this is dimensionless. So it will become, so the dimension of this will become 1 by t. It is equals to t inverse, that is the dimension of frequency, and the unit of frequency is hertz. So therefore option number 1 is the correct one. The unit is hertz. Okay, now the question number 19. A positive particle of this charge accelerates in a uniform field of 100 volt per meter. The particle started at an uniform potential plane of 50 volt. After t equals to 0.002 seconds, the particle is on an equipotential surface of V equal to 10 volts. determine the distance traveled by. You have to calculate the distance. For that, you have to take into account the work done formula. So work done is given by W equals to minus Q into del V, or the potential change, what you can say. The first one, the potential, last potential or the final potential is 10, initial potential was V, 50. So therefore the change in will be equals to 10 minus 50, that will become 40 joule only. Okay, here the charge is minus Q. Okay, I'm sorry, minus is already there, so minus it will become 40 joule. Okay, and we also know the basic formula of work done, that is the force into displacement. Okay, so in place of force you can write QE, right? This is mentioned in the electrostat part. F is equals to QE. So put all the values, you will get the D is equals to 0.4 meter. So therefore option number 3 is the correct one. Just basic simple formulas will be enough to solve this kind of numericals. Question number 20. An electric field of this exists between the two parallel plates of the distance is given. This is D. This is the electric field E. If a drop of water of charge this is placed between the plates and released, calculate the potential energy of the water drop. We have to calculate the V. The value of the calculation of V is very simple. Okay, so electric field is given, separation is given. So their formula is V equals to the potential, or sorry, the slope of potential is given by the formula V equals to minus dV by dr or minus dV by dx, what you can say. So it is nothing but the V by R. So here E will become, sorry, here V equals to E by R. So E equals to E to V by R. So V will become equals to E into R. So put all the values, you will get the value of V is equals to 200 volt. Right? That is the value of V. The potential energy given by the formula Q into V. Q is this, V is this, so the value you will get the answer 10 to the power 5. That is equal to question number 1. Okay, question number 21. Okay, this is the first coordinate. Just do this thing. X, okay, for X, this X equals to Y plus MC. Sorry, Y, My plus C, sorry, not MC. Y equals to My plus C. So if you just take this here, C minus 7. Okay, and X will be over minus 4 by 2, that will become minus 2. Okay, and the C is equals to also like the minus 1. So therefore if you put all the values there, so what you will get, this is the thing you will get, the 7 by 2 C, that is our the intercept. X, C is equals to the intercept. Question number 12 or 22. Two charges minus Q and plus Q charges are on the points A and B as shown. Okay, we have to find the graph. Okay, this is the graph. Okay, this is the origin. The minus Q is at the origin, it is at the some distance from this. So to solve this is a very critical one, critical one. So first of all, you know the relation between V and X is inversely proportional. Okay, so their graph will be what? Their graph will be this rectangular parabola. Okay, and next one, now if you plot the graph for two equal charges, like Q and Q are the equal charges but opposite sign and but equal charges. So we get this is the graph. So here and from this here, so if you put this, it will become this. If you combine it, it will become this. So it is, so in the given option, if you can say, so it will become option number 2. No, but the thing is that here in the given diagram we focus on the middle region. Okay, now here we drew the graph for two charges that are positive, but here the charges are minus Q and plus Q. So therefore the graph will be the opposite to this graph. The opposite of this graph will become this. Okay, so option number 3 is the correct one. The reverse it. The electrostatic force on a charged particle located on an equipotential surface is 0. Okay, the electrostatic force, the F is equals to 0, and the common component of electric field is given by this, E equals to dV by dr. Okay, and equipotent potential V constant. You have to say whether the assertion is correct or reason is correct, or assertion is wrong or reason is wrong, or reason is the correct explanation of assertion or not. This you have to say. Just find out. In the assertion, it is said that the electrostatic force on a charged particle located on an equipotential surface is zero. Equipotential surface is a surface where the potential is equal. Okay, so the potential is equal. Potential is equal means potential is constant. So E will be equals to, assertion is incorrect for force on a charged particle located on an equipotential surface is not zero. Like at every point on the surface same. So the potential also constant is not zero. It is like, yeah. Force is not zero. Okay, so force is not zero. But and you also do this formula E equals to minus dV by dx or dV by dr, whatever you say. So that means the reason is correct, but the is incorrect. It is not zero. Force on the equipment surface is not zero. It has a value. Give the charge. Okay, now question 24. Variation. Sometimes it is 27, sometimes 9, sometimes it is 8. 37. That is the 3. Each radius them are charged the same potential V1. They can they are combined to form a bigger drop. Okay. So the potential of the bigger drop is V2. So up to V2. So first of all, what formula is used? So here it is given the to Q charges, 27 small Q charges are attached together to form a big sphere. So it will become the charge of the big sphere will become 27Q. Okay, so Q is given if the R is bigger, so therefore if we apply the you can say the volume of this thing will remain same. Volume of this 27 charges and volume of this one charge will be same. Okay, so volume formula is 4 by 3 pi r cube for a sphere. Okay, so if you calculate this, R will become 3r, as I told you 3Q, so it will become 3 only. Okay, V is given by the formula KQ by R. So V2 is given by also the formula KQ by R. So put the value, what we will get, V1 by V2 equals to 9. So therefore option number 2 is the correct one. Question number 25, significant figure, very good thing. Okay, so in the significant figure, what you have to do? Significant figures are the number that add to the precision of the overall value of the number. Yeah, so mentioning zeros, non-zeros, rounding of the certain digits, the result of the computation with the approximate numbers. Okay, so the rule of rounding numbers is if one number is greater than 5, so therefore after decimal, so if one number is greater than 5, so here you can say that the previous number can be increased by 1. That is the main purpose of this numerical or this question. So here it will become, so if you consider the only 4 significant, 5 big significant digit like this, 4 significant, 5, 3, 4, 3. So after that what you will get? You will get the 5, 9, that is equals to 9 is greater than 5, so it will become, so the previous 5 will become 6 and 6 is also greater than 5, so therefore 3 will become 4 as it is greater than 5, so therefore it will become the significant digit will become 5.344. That means option number 1 is the correct one. Just remember this, if any number after decimal is greater than 5, what you have to do? You have to increase the previous number by 1. Sorry. Okay, find the value of sin square 50 plus cos square 645. Sin square 645. Sin square 645, how can we solve it? Sin square 645? It can be said 630 plus 15. 630 means 7 into 90. Okay, so 7 is an odd number. Okay, 7 is an odd number, so therefore sign will change to cos, and 7 into 90 means it is in the second quadrant. Second quadrant is the quadrant of sine, so therefore no signs will change. Okay, so sin square 15 plus cos square 15, sin square theta plus cos square theta will become 1. That is the basic formula. Question number 27. 3 charges, this Q1 and Q2 are given, Q3 are given. This flux is like surface area S1, S2 and S3 given. You have to calculate the electric flux. Electric flux is given from the, you can like take the reference of this, what Gauss's law, that is equals to what to say, E dot ds equals to q by epsilon. Okay, E means the electric field, ds is the surface area. Here the surface area is given as S1, S2 and S3. Okay, so first of all, what to calculate this, you have to know the value of E only. Okay. So this is 1 microfarad, this is 2 microfarad, sorry, 2 microcoulomb. When these two bodies are like okay, when these two are combined, or it is inside this the surface, sorry for that. Okay, if when the identical bodies of charges q1 and q2 are brought to contact the separated charge, then the separated charge of each body will become q total charge divided by 2, half of the total charge. So q1 and q2 will become 1 into minus 2 divided by 2. So here the value is given, so you can say if we put the value, you will get this. Okay, so, and we know from the Coulomb's law equal to q by 2, so f1 by f2 will become q1 q by q1 dash q2 dash. Okay, just put value here, you will get the value of minus 8 by I by f2. This is all from the Coulomb's law formula. Okay, question number 28. Okay, I thought I was question number 27. Okay, question number 27 we are going to do first. Question number 20 already discussed, so this is the time for question number 27. Okay, you calculate the flux. Flux is given by bs. So flux, yeah, it is given by the formula q by epsilon naught. Also q by epsilon naught. You can take the of, sorry for the time. Okay. Question number 27. So flux is given by q by epsilon naught from the Gauss's law. Okay, so total charge is q is given. Okay, q1 q2 is given. Okay, so it will become 2 minus 3. So because of this all of this, the total surface of the Gaussian surface is 0. Okay, so total charge enclosed here, this one is like not here, so it will become 2 minus 3 by epsilon naught, it will become minus 1, and epsilon naught is given by the formula 4 pi 1 by 4 pi, k is given by epsilon is given by, sorry, epsilon formula is k formula is 1 by 4 pi epsilon naught, so epsilon naught will become 4k pi or 4 pi k. Okay, and the value of this 1 by 4 pi epsilon naught is given by 9 into 10 to the power 9. Okay, so if you just put all the values, you will get phi 2 equals to minus 36 10 to the power 3. So it is that means option number 2 is the correct one. Question number 28. Two small conducting spheres of equal radius have charges of this. Already discussed the question number 28 previously. So if you have any confusion, like, do comment. Question number 29. In an experiment, this and this and this are given. Okay, so you have to calculate the for this. Already told you this. We have to take into account the exponent part. Okay, so it will become 2a plus 1 by 2b plus 3c. There is no such thing we consider while calculating the divide. If there is division, if there is a multiplication, we don't take into account this part. We just put the plus sign between them. 2 into 2 means 4. This will become 1.5. This will become 4.5. So the total answer will become 17.5. That means option number 3 is the correct one. Just remember this. It doesn't matter whether it is division, whether it is multiplication. The error, when we have to calculate error, we have to add all the errors. What is the amount of work done moving on this particle from 2 points from 3 centimeter above on the equipotential surface? In equipotential surface, the potential remains equal. Okay, as per W, work done is given by the formula Q, W V is equals to W by Q. That W will be equals to V into Q. In the equipotential surface, if we like, as the surface is equipotential surface, the charges are same, therefore work has no potential difference. So therefore will be 0, as the difference is each case, like at both ends is equals to 0. So therefore W equals to Q into V. So Q will become 0. Q into potential. There is no potential difference. Therefore V will become 0. That means that will be become Q into 0 means 0. The what will be 0 only. Right? Question number 31. A ring of radius. Charge through Q uniformly distributed throughout the sphere of the radius. Circumference is less. Therefore the surface, the flux. Have to get flux. That's the same Q by epsilon. Okay, give a figure, this figure, we can calculate this figure. OA and O1A, this one, these two are equal. So let us take this. So and this is from the center. Okay, so and AOB, this will become 120 degree from symmetry. Okay, so this is 120 degree, and these two 120 degree, will become 360 degree. Okay, now to the arc length is okay. Is given by the formula theta by 2 pi into 2 pi r. That is the nothing. That is what I said. Okay, so if you just calculate it, L will become 2 pi r by 3. Okay, so for the second charge, radiant charge, that is Q, and the unit radiant charge is Q by 2 pi. Okay, so and Q by 2 pi charge, it is become Q by 3. So therefore, if you calculate the value of this, so it will become Q by 3 by epsilon naught. So it will become Q by 3 epsilon naught. Okay, question number 32. It is from the like what to okay, question. An inclined plane making an angle 30 degree with the horizontal placed in uniform electric field of this E. A particle of mass 1 kg and charge this is allowed to taken from the rest of height of 1 meter. The coefficient of friction, okay, mu. What to calculate mu? Okay, first of all consider this a wedge, inclined plane. Okay, so if you just solve this, the free body diagram. Okay, so it is become, this is become mg sin theta, and this will become g omega r plus q cos theta, the total force. So mu r, sorry, not the gr, mu r. Okay, so if you put all the values, f net is, and these two are acting in the opposite direction, so therefore there will be a negative sign. That is the this subtraction is there. They are opposite, moving in the opposite direction. If they are moving in the same direction, it will be plus. Okay, so here the angle is given as 30 degree. Okay. R is the reaction, normal reaction. It is mg cos theta plus qe sin theta. So you put the value, you will get the value of f net. Just put the value here. So put the value, you will get the answer. F net is equals to 2.3 Newton. Okay, just let us search for this. Okay, 2.3 means 2. Yeah. So this is f net. In the given figure, what you can say, sin 30 degree is given by the perpendicular by hypotenuse. It will become h by s. So it has become s equals to 2 meter. So if you calculate this sin 30, and that is half, so it will become, s will become half. So put the value s equals to ut plus half at square. So put the value, all the values at the initial velocity is 0. So therefore ut term will be 0. So s is equals to half at square. So T, you have to calculate T is equals to root over 2s by A. Okay, value of S is 2, that means 4. Yeah, just put the value here, you will get the answer. This half of F by M. A is equals to F by M. F is 2.3 and A is equals to 1. So therefore, if you put all the values, therefore T will become 1.37. Find the from the intensity of the magnetic field. Magnetic field. This is a very common question. This is a PY question, I think. Okay, previous year, I think some previous year it is there. F equals to 2V for magnetic field. Magnetic field is given by this. B equals to F by QV. F is force MLT minus 2. But first of all, dimension of QQ means A. This is TQ8. Okay, already know. V is the V is W by Q. Okay, so WIT. So we W. So put all the values in the above equation first. With that, B is equals to MLT. We will not T minus 2, A minus 1. A is the unit of, the dimension of this current flow. Question number 34. This is the infinite series. Sorry, not infinite. How many resistors are there? So in this kind of thing, na. So what to these three are in series. These three are in series. Okay. So series means it will become 3 by 3. It will become 1. And 1, this is related to this 1. So it will become 2 plus 1, 3. This is related as parallel. Parallel equals parallel in CP. The CP will become C1 plus C2. C1 is 1, C2 is 2. So therefore C will become 3. So if you calculate for all of this, the same answer will come. So it is equals to 3. Okay, so 3, here it is 3, here it is 3. So after this 3, so this is 3, 3 and 3. Okay, so these 3 are in series only. So therefore it will become 3 by 3 equals to 1. Or you can put this formula. From here you can also calculate. This is a simple formula. Whenever this capacitors are in parallel, it will become same capacitors. So it will become C by N. C is here 3 and N is equals to 3. So therefore number of this will become 3 only. Oh, sorry, 1 only. So therefore option number 1 is the correct option. Option number 34. Electric field is given. Electric field is given E. You have to calculate the flux of radius 1 meter. First of all, calculate the square area, that is 4 pi r square. 4 pi into E, this. Okay, so I have to calculate this. Okay, so I have to calculate the electric flux. Electric flux is given by the E into ds. ds is the 4 pi r square. So put the value here. So what you will get? First of all, calculate the value of E. E is equals to root over of 2 square plus 6 square plus 8 square. So that is equals to 64 plus 36, 100. Okay, as the total charge inside the sphere is here. Okay, and inside as I already told you, the charge is only present at the surface. So inside the charge is equals to 0. So therefore, inside the flux will be equals to Q by this 0 by epsilon. It will become 0 only. Okay. Now question number 36. That is the section B question. Force F, time R, 1 terminals. Plus mass. Mass is given the formula by from the Newton law, and A is given by the formula L by T square or L T minus. So that option number 1. Question 7. Okay, x 1 by x plus 1. Okay, x plus 1 is given by the formula. Okay, on this 1 by x is equals to ln x. Okay, the integration of 1 by x equals to ln x or log x, whatever you can say. For log it is the base of 10. For ln it is the base of log e log. So if you get, you will get ln x plus 1. So the put the limit now, it will become 1 plus 1 2, and this will become ln 1. So ln 1 has the value of 0, so therefore it will become ln 2 only. Okay, so this is the figure is given. What you have to calculate is the figure of such capacitor is filled with dielectrics as the resultant capacitance is. What you have to calculate? The resultant capacitance. 38. If you see the figure, na, these two are in parallel, this is in the series. Okay, so here C1 C2 is, so C equivalent will become C1, these two are parallel, so these two are series, so therefore this two will become C1 C2 divided by C1 plus C2, along with this C3 is in the, like, in the parallel, so it will become plus C3. So if you calculate all of this in place of C, the formula C is given by K epsilon naught alpha by D. It will be there in here, it is there, but after, like, yeah, so for any other medium it will become K. Okay, K epsilon naught alpha by D, that is the simple, yeah. Okay, so put the value of the, so therefore you can say for all the cases the A is equal, so this is A by 2, this is A by 2, okay, and epsilon is equal, so therefore if you calculate this, what will become? C equivalent will become C by C into K1 K2 divided by K1 K2 divided by K1 plus K2 plus K3 by K3 by 2. Just here the concept is there, the what are in parallel and what are in series. Okay, question number 39. 2 point charges plus Q minus Q are located at the, okay, that their position is given, their locus is given. So potential at point 0 0 0 Z. Okay, so this is a very simple one. So charge is minus Q, charge is here, minus Q charge is here, plus Q is here. So they are in the both are in the like Z axis option, and dipole at 0.002. Okay, so for this the dipole will form at the xy, this dipole will create in this plane. If you take this and xy, this and z, so dipole will form in this. So the potential at point Z, yeah, to calculate. Okay, so potential is given by the formula. Okay, what to do, like, okay, V is given by the formula 1 by 4 pi epsilon naught Q by Z minus A for the first, like, X plane, and Y plane this is minus Z minus A. Okay, so if you calculate all of this, the V, the total V due to this these two charges minus Q and plus Q. For plus Q, this is the V is given by the formula 1 by 4 pi epsilon naught Q by R. So here R is Z minus A, here R is also Z minus A, because both of these are in this. Okay, but here in this case here will be a minus sign because of the negative charge. So if you calculate all of this, what will, so this is not, this one will become first one minus Q charges minus A. Okay, so this will become plus A. Okay, so this will become plus A only, so it will become Z plus A, as minus a is there. So if you take the LCM of these two, you will get a minus b into a minus a plus b. It will become z square minus a square minus b square formula. So if you put all the value, you will get 2qa 4 pi epsilon naught 1 by z square minus a square. So here in place of this there will be a positive sign. Okay, understand this. In place of my plus a, there should be a minus a. Minus and minus, it will become z plus a. Okay, dimension of the impulse are equal to that. First of all, understand this. Impulse is given by force into like time. So it is equals to m into v minus u. That is the change in the momentum. Change in the momentum. So therefore implies so therefore this will become m into v minus u, which is therefore we can say impulse dimension as the same as the dimension of momentum. Okay, linear momentum, not angular momentum. Angular momentum is another thing, I omega. Okay, two charges plus q and minus q charges are there, but you have to calculate the potential at a vertex A. Here you have to calculate. So this is the basic thing. Okay, basic thing. This is the mentioned in the different books. So it is a direct question from there. You have to remember the formula. Okay. So V, total V due to B and due to A, total V should be there. So V, B and C. So net V. So here it is k by r a. Form is a. This is the a. So therefore you can say not a. So it will become root over b square minus s square. So if you take this both of the opposite directions, so therefore resultant will be equals to 0 only. Okay. So therefore their resultant will be 0. Question 42. Potential V resistance respect to R on the given side. Why the following? Okay, B given by the formula B to 1 by R. I think you guys know this. As the proportional is a rectangular parabola. So this option number 2. This is a rectangular parabola. This one, inversely proportional graph. Inside there is that sphere is a constant potential, so therefore there is a state of the sphere. There is a relation is this for inverse proportional relation. There is a graph looks in rectangular parabola. Two capacitors of 20 and 30 are connected in series, so therefore this will become CPU CES will become 20 into 30 divided by 20 plus 30. Okay, so it will become 50 and 600. It will become 12. Connected to battery, calculate the energy on each capacitor. So first of all, total energy, calculate the total energy, that is equals to half CV square, half 12 into 40 square. So it will become 6. It will become 9600. Okay. So first of all, to calculate the energy in each capacitor, what you have to do? So 960 only. It will become 960. Okay, so this is given as they are connected in series. Therefore, the total each capacitor will be equal charge. You have to calculate the total charge. Charge is given by the formula Q equals to C into V. As they are connected in series, so therefore the charge we already discussed that. Therefore, the charge flowing through this will be equal. Okay, so C already got 50. Sorry, not 50. It is 12, and V is 40. So therefore, the Q will be equals to like Q will be equals to CV. C is 12 and V is 40, so it will become 480. Option number 1 is the correct one. Okay, this is an infinite series also, like that series, infinite that series also. Okay, 4 microfarad, 4 microfarad, 2 microfarad, 2 microfarad, 2 microfarad connected to a 20 volt battery. Okay, so first of all, what can you say? This is an infinite ladder circuit. Already told you that. So it can be written as this: 4 microfarad here, 2 microfarad, 20 volt, and this is the equivalent. Okay, so what is the equivalent? First of all, see this, these and these and these are in series. Okay, so therefore their equivalent is, this will become 4 into CEQ divided by 4 plus CEQ. Okay, now these two, these two will be the common capacitor from these and these will be equal, are in parallel. So therefore we can say, yeah, C1, this C1 will be parallel to this C1 plus 2. Okay, so put the value of C1 here in this equation. So solving this, you will get a quadratic equation. From that quadratic equation, you get the value of C equals to 4 minus 3, as the capacitor cannot be negative, so therefore C equals to 4 microfarad. So calculate the charge. To calculate the charge, Q equals to CV. The formula Q equals to CV, and already got the C equals to 4, so it will become 420. That is the total charge is 80 microfarad. Now calculate the energy. Same formula, half CV square. You will get the value 800 megajoule. Sorry, millijoule. So 3 driving charges plus placed in the vertices of the equilateral triangle means all the things sides are L. Another minus charge is the centroid of the triangle. Here is the given in this. Here is the given figure. Okay, the size 60 degree from feet draw perpendicular 30 and 30. Okay, so calculate the force acting. It is acting in this direction. This will be Q square 1/4 pi epsilon naught Q square by L. Q charge is here. This is the length. This is L. This is L and this is also L. So it will become distance is L square. Same for this this F2. F2 will be same. So their resultant, to calculate the resultant, we have to apply the vector law also. So that is given by this FA plus square F square A plus F square B plus 2 FA FB cos theta. Here the cos theta is given by like what, 30 degree. So 30 degree cos 30 degree means root over 3 by 2. Okay, yeah, this one. So this still, so you can calculate the value. This is 1 by 4 pi epsilon naught 3 Q square by L square. So now while F3 due to this the charge here, so F3, so this is that you have to calculate by this also, root over 3 plus 3. Okay, now to calculate the work done, energy stored is given by the formula E equals to FR into D. Here the displacement of the charges, is given by the formula root over L square plus L square plus L square root 3L. So multiply this this total force, the resultant force, with this distance, force into distance, you will get the energy. That is a simple formula. Root 35R is given. Okay, calculate the formula is there. This, so if we calculate this, V will become R square plus root over 35 plus R square, the total distance. Okay, so it will become KQ by 6R. So V naught at the center, it is KQ by R because the radius is R. Okay, or the distance is R. So for, and that for A point it is minus A. It is equals to KQ by 6R. So if you like subtract from each other, it will get 5 KQ by 6 square. and work done is given by the formula minus QV as the negative charge is moved. So minus Q into 5Q KQ by 6R. So it will become minus 5 KQ square by 6R. So therefore the option number option number 2 is the correct one. Okay. C1 is this, C2 is this, these two are connected in parallel or series. As the potential, this is, there is a key, like it is an open position. As these two are connected in parallel, so therefore their charges is not equal. Okay, but their potential is equal. So therefore you can say, as we know, Q equals to C by V. So Q1 equals to C1B, Q2 equals to C or C2V. VV cancel out, you will get this C by 3C. So that means Q1 by Q2 is 1:3. Q2 equals to 3 Q1 from this. So a total charges Q1 plus Q2 equals to Q1 plus 3 Q1 equals to 4 Q1. Okay, so therefore Q1 will be equals to Q by 4 and another one is a 3 Q by 4. That is a simple thing. Sin 75 degree, cos 75 degree. For this kind of numericals now where the angle value is like this weird, what you have to do, first of all multiply this with 2. So you will get 2 sin 75 cos 75, it will become 2 sin A sin B, that is equals to sin 2B. So it will become sin 150 degree and there is a half multiplied because we introduced a 2. Sin 150, like you can do one thing, sin 90 plus 60 into half. 90 means, so it is a not odd number. Odd number means sign will change into cos, and that is the quadrant of second quadrant of sign. So that means it will be a positive sign. So that means it will become cos 60 into 1 by 2. Value of cos 60 is 1 by 2. So 1 by 2 into 1 by 2 it will become 1 by 4. Okay. Question number 949. Okay, the 49, two metal spheres of radius r and 2r respectively have the same surface charge density sigma. They are brought in contact and separated. What will be the new surface charge densities? Okay, first of all they are contacted, then they are separated. So sigma is given by the formula. Q is given by the formula sigma by epsilon. Okay, sigma is equals to Q by 4 pi r square. Q equals to this. So Q1 equals to this. So Q2 equals to 4 Q1 according to the like this given. As r is equals to 2r, so it will become 4 Q1. As we know, they are connected. When they are connected, both after separating, they have the both have the same potential. Okay, so potential be like so in that case you will get V1 equals to V2. Okay, so and we take at that the final charges are Q3 and Q4. So V1 will be equals to Q3 by 4 pi epsilon naught r. It will become Q4 by 4 pi epsilon naught. There will be a by sign. So if you calculate this, you will get Q4 equals to 2Q3. Okay, so if you just add this, what you will get, Q1 plus Q2 equals to Q3 plus Q4. So after adding all of this, what you will get and putting all the values, what you will get, sigma is equals to 5 sigma by 3, sigma 1 equals to sigma 2 equals to 5 sigma by 6. Question number 52. Charge conducting spheres of radius 10 cm 20 cm have the same electric field near the surfaces. The ratio of their electric potential is, radius V is proportional to 1 by r. So V1 by V2 will be equals to 20 by 10. So it will become 2:1 or 1:2. Same electric field near the surface. The ratio of the electric potential is. Here EA equals to EB. Okay, so EA means KQ by R square. So KQ by R square. So Q1 by Q2 equals to R1 square by R2 square. In case of this, so you will get B KQ1 by R1. Okay, as the charges are not equal, you have to take into account the charge also. Okay, so V2 equals to KQ2 by R square. So VA by VB will become KK cancel out Q1 by Q2 like R1 square. R2 square by R1 square. Okay, as Q1 by Q2 is equals to what did you calculate? We calculated Q1 square by Q2 square equals to, sorry, not Q1 square by Q2, Q1 by Q2. We calculated it. Q1 by Q2 equals to R1 square plus R2 square. So that means here what you will get, KQ square V1 by V2 will be equals to K1 by K2. So Q1 by Q R1 square plus R2. So R2 by R1 cancel out, so it will become R1 by R2. So it will become 10-20. So the ratio will be 1:2 only. So here all the charges, in both the spheres, the charges are not equal. So what you can say, V by VB equals to 1:2. So yeah, so you cannot calculate this from this formula only. Okay, you understood all the numericals, all the questions that are asked. Okay, so best of luck for your VB and preparation. So if you have any doubt, do comment. I will try to solve it as soon as possible. Thank you.